also we need to put on our note card. No, I had to go to this bus and it's an hour short. And then I forgot about the Verizon and you and the Verizon. Look, these are all the connotations.
I was like, oh.
Active, passive, active, passive, active, passive, active, passive, active, passive, present, and then active, passive, and then active, passive, before I meet you, and then in the passive, the second person singular changes to the like, this is so She did that last time. She did it. Yeah, she did it. She'll probably do the imperfect. Can we please do one problem of each? This is our doing one problem of each thing. And then just go from the beginning. We can do it to the end. And then we do one problem of the math problem. Or talk about like each concept. And then we can do whatever we want after there's time.
Sure. Late. All right, review pass.
Oh my gosh, the new Mission Impossible movie is so good. I watched that until like 12 months.
More than 3.
No, it just came on Netflix.
Oh, that's.
It was so good. And the evil guy that's in it is the guy that's in the fire, and my dad thinks he's like already dead. So we had to start at the beginning.
Yep, here's where we left off. All right. What problems we need to know? One of each. Sure. We can go through and do one more. Something like that.
Yeah.
Or we can jump around.
But is everything we need to know on this packet? You're not going to throw a range of problems?
Oh, that's it.
Okay. I'm going to hold you to that.
We'll throw away when all this color rolls.
Have you made the test yet?
Nope.
You only you make it after like the next.
And I know what you guys are going to say. This one I'm gonna test it. I'm gonna take it and find the errors. Are you mumbling it as well?
I did.
I'm not going to say anything.
Okay. All right. Let's do some standard units real quick.
Meters.
Meters, what's next?
Meters.
What's next? What do you measure impact in? I heard it. Yeah.
Oh, minutes.
The force. Momentum.
Meters per second. No.
What is
Well,
momentum?
it's a force and,
It can be, yeah.
yeah, it's force and a mass.
No.
Yeah, in the little thing boxes we do.
What is momentum? Just think, what is it?
Mass.
Gaining. Oh, gaining.
No, that's not momentum, that's acceleration.
You have momentum.
You have momentum, so a train has momentum, right? A lot of it. What makes a train special that gives it lots of
It's
momentum?
weight.
It's mass.
Mass. I said mass.
So, yes, it is a force. It's mass and what?
Velocity.
Yes, mass and velocity. There, not square. Acceleration. Right? Mass and velocity. What do we have for mass?
Kilograms.
Kilograms. What do we have
Meters.
for velocity?
So it's kilometers times.
Kilograms.
Over second.
Kilogram, not kilometer.
Yes. You guys are gonna have a hard time. We're still measuring mass in kilometers. Let's go. Let's go. Wake up. 8 a.m.
Impulse is.
Oh, it's more like.
It's behind
N times S.
you. N times S for impulse. Newton seconds. What's interesting about Newton seconds and kilogram meters per second? They're the same thing. All right, good. Other units.
Distance could be kilogram.
Distance.
Kilometers.
Miles, kilometers, feet, right? Yards. Velocity.
Would be like
Miles per hour. Kilometers per second. Kilometers per hour, right?
Kilometers per minute for the next one square.
Kilometers per minute squared.
That's really long.
Oh, that's perfect. What else? How about miles
Miles
per hour per second?
Isn't force still units?
Well, what's another unit of force? What do you measure your weight in?
No.
Right?
It's same as
No.
Yeah?
Pounds is a force, right? That's how hard are you pushing on my back.
It's the same for some. Yeah, it's. Isn't that watts thing?
Pounds?
One of them is pounds. Yeah, one of them is watts.
Yeah, another one is pounds, but like 3 pounds of it.
Yep. There's another one on this list. Right? Anything that's a force.
Wait, so I think that is a movement.
Another unit would be pound. Right? Because newtons are a unit of force, pounds are a unit of force. Right? Mass, kilograms. What else?
Pounds.
No. Pounds are a force. Mass is just how much stuff something has, how much
Grams.
inertia it
Yeah,
has.
grams.
Grams. What else? Milligrams. What else?
What, move on.
Metric ton. All right. Momentum.
Grams times kilometer. Yeah, calories per minute.
Perfect. How did you get that? She used a mass and a velocity. Put them together. Anything. It could be a milligram mile per hour. Pound minutes, sure. You guys are figuring this out. How to make other units up. Is anybody ever going to measure impulse in pound minutes? No. But
Good.
it's totally legit.
Okay. Let's do one.
We talked about this last time. When you land an Olympic ski jump, why is it a good idea to catch me?
I have a perfect answer. No numbers. So you have more time. No.
You have more
It's
time.
on the first page.
No.
More time of something.
It's on the
Not
first
more
page.
time to fall.
Oh, yeah. Right here.
No, I have my own answer.
Oh, yeah, where you filled it in is right
Give
here.
her this one.
Oh, it is?
Yeah.
When you bend your knees, you lengthen the time that the force is applied.
bend your knees. You slightly forward. You extend the time over which you are stopping your momentum. This reduces the force. It won't be exactly this. Everything will be a little bit, maybe different. All right, Newton's third law. You guys know this one. All right. I want you to write out if this is a test question.
For every action, there is an equal or opposite.
And we're
Make sure you're talking about the force.
we're not
The reaction force.
we're not asking about the same
So,
Those.
I know you might be. What's Newton's first law?
Wasn't that before?
Yeah, that was before we should get on our midterm.
First and second round.
You still need to know that.
Well, no.
You need to know Newton's three laws.
2 is F equals whatever. Or F equals M equals.
Yes.
No, but that's
F equals
that's
M.
slow. That's slow.
Yep.
It's M
Force
equals
equals
F
mass
equals.
times force.
Force equals mass times acceleration.
Yeah.
Yep.
Yeah, F equals M.
So
That's the
F
second
equals-
one.
You actually know stuff.
Second is M equals F equals.
Right, and then one. Yes. One is the acceleration of an object is proportional to the force applied to that object and inversely proportional to the mass.
Right.
Oh no, that's the second one.
Yeah, Mr.
Same thing, the second one. First law, inertia. That's the one word answer to that. An object in motion tends to stay in motion. And an object at rest tends to stay at rest. Unless acted upon by.
Outside inertia.
Not an outside force necessarily.
It says in the definition.
Yeah, outside, I like, there's a better word than that. Unbalanced. Unbalanced force.
Imagine a car.
Are we doing every single one?
You don't have to. Skip around, you guys think you got this one?
Yeah, this is all about.
Newton's third law, right? How does Newton's third law apply?
Because there wasn't reaction. Because the car hits Bell, it's car.
There you go. That's what I'm
It's
looking
like the donkey question.
Yes. Donkey pulls on the cart pulls back on the donkey, so the donkey says, why should I
It's the
bother?
same way, yeah.
Equal force, right?
Okay, let's go.
Why do we say total momentum's the same?
Total momentum before the collision equals total momentum after the collision.
So you add the momentum.
As I
The
said.
sum of the momentums
so
before
much.
is the sum of the momentums after.
Okay,
Right.
so.
The sum of the momentums before equals the sum of the momentums.
Okay, so which of the greatest changes in momentum is the same mass as the body? We can jump to the one.
Neither is the same.
The first is the second is
Remember, like when you put your egg, you just put your egg not even wrapped in that thing, and then our groups put it like wrapped and stuff, and there's cracked resin. This is what I think.
What is your
Just cracked
greatest
and
change
like
in
move around the
momentum?
box.
This whole test question is based on the fact that you guys did a whole lot.
I can tell.
So what is the greatest momentum?
Either.
Which is the greatest change in momentum? So it's going from however fast and massive it is to zero, right? If it's stopping. So they're both hitting the ground with the same velocity, right?
Yeah.
And they're both with the same mass, right?
Okay,
So change in
what?
momentum.
No, they're not the same mass.
Either it's the same.
Uh, the foam is massless.
Which experience is the greatest influence?
neither it's the same.
No, because Jared.
You're just reading off the answers, I want you to know
No,
what.
this is my test.
Okay. No, but you're reading your answers, I want you to actually think. Explain it.
Wait, isn't it their attitude because there's nothing to observe?
They don't, there is no different impulse because they both get dropped.
No, the impulse,
And they both hit the same floor.
I like this discussion right now, but I want you to tell me,
no,
what is impulse?
no, the impulse is like, how much
The rate
it
of what you hit.
changes. No, the impulse is how much it changes, the velocity changes, no, the momentum changes from the beginning to the end.
Right.
And
The neither is the same.
Yeah.
The momentum is there. It's the same.
Which one? Impulse is the same as change in momentum,
yeah.
Oh,
So-
yeah, you should just say that.
right?
Okay, so then the impact is the variable,
Yeah.
because of the, when you,
Yes,
because, yeah.
right,
Because it
because
has less protection.
there's less protection, so there's no foam. What does the foam do for this other one?
Slows down the.
It extends the time.
Extends the time, like the ski jump.
Exactly.
Now we
Which
don't,
feels the biggest force? The bigger angle. Which is the greatest change in velocity?
no, we didn't do the last, the one time it's the greatest change in all, or.
Yeah, just ask that.
Okay, we need to do the second one.
Yeah, this one's different. Now, the first one was two things of the same mass,
It's
right?
like the bee and the bike.
This is like
Yes,
the
the in the bus.
B and the bus, right? The bicycle and truck. A little less difference between masses, but again, both very different masses. So, which feels the greatest force?
Neither.
Why?
Because it was no single force. It-
Truck hits bus, or truck hits bike, bike hits truck. Equal and opposite,
Yes.
right? Force is the same. That's tricky, right? That's tricky. That's not your intuition.
Neither of them experience greater impulse because they don't have a different.
Which one has a bigger change in momentum?
No, that's
The bike.
fine.
No, the
Neither,
truck.
neither.
No,
Neither.
the truck.
They,
Why?
they don't,
Because,
because they both hit each other, it's like it's one.
Right.
So it's like the same thing.
So whose momentum changes?
No, neither, none of them. None of
It's
them.
the same, right? Yeah, now, keep that in mind, I know this feels weird, right, to say this. Their momentum change is the same. The bike's momentum changes by, I don't know, let's say 100 kilogram meters per second. The truck's momentum changes 100 kilogram meters per second the other way, right? When they hit, the truck is slowed down a little bit. The bike is blasted off, right?
yeah.
But the bike has very little mass. So, same impulse. Change in momentum. Same. Which one changes its
The
velocity?
bicycle.
Right. Okay, bicycle its velocity.
Oh, yeah, we need to do it over.
You want to do one of the table problems?
Yeah. What?
We did one that I made up.
Just do the one that.
Right, this isn't the one that goes with this problem. This is what we did on the
Yeah,
board.
so let's do number 3.
That's good.
All right, good.
Okay, can we try by ourselves?
Yeah, take a second. I'll put after this.
Did you up our grades?
Up your grades. I did grade some stuff. Still got plenty to do.
I finished them all. No, I did this for that. Well, I did the reading tutor, and then I did the other two tests by myself. Actually, yes. And then I'm like meeting with the school today.
I only think she does junior,
Yeah, Heidi Lewis is she does.
the parent system.
He's no.
No, it's
He
a girl.
figures out. Paris is a boy. It's except
So there's another girl.
Yes, but Paris' tutor figures out how like learning homeworks. They don't just do English. He like.
All right. I'm talking about tutors before.
Finished.
Okay.
You guys,
Doing it right.
you guys can start. It's a review that.
Well, where?
Terror. No sass.
All right, did everybody turn in their rocket experiment?
Yeah, I see.
Okay, so
I only
I
have one from Anya and Isabel.
We're
Print it,
cool.
okay, oh, and you handed it to me. Yeah, I did see it, it's on my desk. Email, okay, so yours came in email? Email? Alright, that's everything, alright, good, I just wanna make sure.
I already had it. I got it.
Oh, that's in your bag.
Only five.
Or for graduate, you know, worry about it.
Special interest.
Oh, I'm wearing a dress, but you don't have to.
It's gonna be hot, you should wear a dress.
I already have one. I left it out.
Oh, because you guys packed, right?
Yeah.
You need a dress for baccalaureate. Alright, what do we at?
Wait, what did you say?
The missing number is 2.
What?
Speed for the first object.
Alright, so Lloyd, you knew.
After collision.
It is two. It says it's, oh, it says it's -4. Oh, I put the second object
First object, second, that's the number you're trying to
Oh,
find.
you did it opposite, Isabel?
No,
Morning,
you just said the second object.
First.
They both
Yeah, oh, no,
start
yeah, no, now I know. It's
Fourth
easy,
plus
the second
zero,
object.
zero.
It's easy, you guys know what to fill in. You only know how to fill in for part of that.
I got that.
Negative 4 is speed.
Yes, and then the time.
And then
you get,
-8 in momentum.
and then you get
Means-
80 error, and it's 2.
Error 2.
And then the impulse is 80 and the other one is -80. So
Alright, you guys got those now. Alright, we did some conversions last time.
yeah, we're,
Alright,
you can try one.
one conversion, I think there's another one later.
But it's not gonna be converted. Where are we?
Oh, no, it doesn't include the conversions.
We just think they're giving us the whole good stuff back. We don't have-
Wait, can you just give us?
Every good stuff on this, on all of these tests will all be combined on one page, plus probably a couple more things.
Can we just do kinetic energy, potential energy, working power, like powers, watts?
Okay, only you need to do that, we don't.
Units,
Yeah, we'll do.
Yeah.
We did those.
kinetic energy, potential energy,
Oh, we did?
We did those last time when they were on Veracross.
work,
T.
Forces, newtons.
what are other units for energy?
Calories.
Oh, yeah.
How about power?
Kilowatts.
Horsepower.
Oh, yeah, horsepower, that was good.
Force is newton.
No, we
Oh,
already.
wait, you don't need
Yeah.
those.
Those are the new ones to this unit, so it's just.
Yeah, sorry.
Alright, so these multiple choice are actually like test-taking skill questions as well as content questions. Right?
Yeah, I could tell they were like.
They're tricky, like you have to read
Just have
them
to think
carefully.
about them.
Right, you just have to
It's
think.
like, it's trying to trick you, it's so work.
It's so wordy, you have to like,
Okay, so a
That's what
load
the questions
of
are.
2 stories, so is that 2 stories? Wait, if you lift up 2.
everybody knows what a story is, right?
Yeah.
Your house. Okay. Matt, you doing okay? Alright, hang in there.
Why, Matt, what, no.
It's Monday morning.
Oh, it's
Last
twice.
one.
Guys, we have to sleep until 1
You
o'clock.
guys have a final tomorrow.
I don't care, we sleep.
Do you realize that? Oh my god.
Go find it.
The daughter.
Yeah.
In 2017 changed to sophomore, so that's like 3 p.m. I was like, why am I following a software account? And then I made it on there and I was like,
No, software is not really that big of a deal for cheating. It's junior, it's
Junior, I
it's
can't
the
wait
juniors
to
and
be
seniors.
I want to do junior seven.
Trust me, the biggest difference is.
you want to be a junior so that junior is like the hard.
It's sophomore, junior.
Sophomore is hard.
You guys grow up.
Junior is hard.
It's not that much.
No, we're talking about school.
Alright.
Well, the sophomore class is kind of weird. I think we
Alright.
don't know. It's
Weird.
Back on track, last class, only minutes to go,
To
physics.
be that.
There's only a couple of people.
How many minutes?
Minutes, only minutes left.
Hour.
So weird.
Yeah, we had a 9:20. Wow, it feels like you've been.
58 minutes left.
Why didn't we just do, instead of all short blocks, and then add in another class, because I don't have math, and like.
I have every single class today, okay? Every single
Yeah, so
class.
I don't have
Ridiculous.
geometry.
We have all the same
Yeah, I
classes.
don't have geometry.
I want
and
to
it's
have
like-
geometry.
Yeah.
We should have all.
And then I have my local exam for Spanish. So just throw it.
I like the idea of this last day of classes being 45 minutes or 40 minutes every class.
Yeah, so I did middle school switched every 4 minutes.
I like how they
I have all, yeah. I have all.
Alright, you don't have me until Thursday.
Except for photography.
Wait, taking an arts class boosts your GPA.
Wait, are we first?
Yep.
That's why I say we did it.
Thursday morning, 8:30.
We did a lot of work.
Language is in there.
Regularly every VHS essays.
All final start at 8:30. 8:30 to
I don't wanna
10:30.
like do work.
Unless you're in extended time, you'll take 30 left.
Basically, take me like at least
90 minutes, you have to remain at least 90.
You don't wanna leave.
That's the rule. If you're done,
What's the reasoning?
go over everything.
Make sure that you go to the chat.
It's to make sure that you're not just blowing it off. You just, it happens.
I bet seniors aren't gonna show up. Just had 0 for it. I mean, I would totally do that. We already got involved.
No,
Yes, tell us our grade line.
It's only 10%.
you have,
You have to break them really
you'll get
quickly.
you'll get your report cards.
Yeah, when are we gonna get the exams back?
You won't get the exams back, you'll get a grade posted on your.
How come we don't get our exams?
If you want, just email me, if you want to see it, I'll scan it. Alright.
Alright.
It's hard to do grade papers.
But
How do you have all that time?
teachers are here until Wednesday. We have all the grappling work, grading, meetings, planning for next year. You can stick around if you want.
No, we get
Actually,
kicked-
I-
no,
Actually, no, you can.
we get kicked out of the dorms within 2 hours after graduation.
Yep.
Yeah, I know. Yeah, I know, we get kicked out like in minutes of graduation and it.
And you will, I'm telling you, if you're fluid, Miss Haynes will literally kick you out.
How?
She'll stick her foot on your butt, push you into it.
Yeah, she like get out. Yeah, that's why you have to have everything kind of before graduation.
Yeah. Yeah. Be gone. Be gone. I'm driving a bunch of people here.
Wait, Friday was the last.
So there's so
We have
many.
afternoon free, but the required events are.
We have so many, yeah, we have the afternoon free.
Yeah, there's required time. I don't know. Anyways, back on track.
What?
So that's us.
If you skip it, you can just come for your first attention next year. Monroe National.
It's 5 minutes big. She's having head up herself, professional head
Okay.
up. Okay, let's keep on going to the second question. You got sidetracked.
You can't set up 5 minutes.
Two loads. Two loads up one story
Yeah.
compared to lifting one load up one story.
Wait, if you live,
Oh, two loads up one story versus, so twice as much stuff up than just regular amount of stuff up. What happens? What's right?
This is one that was 4 times so much.
Right? Because
That's the second one.
there is one that is 4.
no, it's
Work equals 4 times distance, right? If it's twice as much stuff, then it's 2F times distance, right? So that's just 2 W's. Alright, if I lift one load up 2 stories, how much compared to one load? That's work equals force times distance, and that's work equals force times 2 distances. So again, it's 2 W's.
Yes, twice as
Great. Alright, how much farther will a car traveling at 100 kilometers
much.
per
But how do you
hour
know
per
it's
second?
not 1/2 as well? Because it says that the load.
Wow. A car traveling 100 kilometers per second is going really fast. That was supposed to be
Number
hours.
2 is twice as much again.
Yes, it is.
2 is twice as much again. Yeah, so twice as much. And I moved it. Did you see that? I didn't put it in the same place. You have to read the answer. This is a tricky one that you're probably going to want to just
I
remember
was
this.
thinking about it, it's 40
So,
Right?
how much further we're going to go?
Right? That has to do with kinetic energy, right?
Wasn't it?
So KE equals, so work equals the kinetic energy of the car, right? Or the negative kinetic energy, which equals what? 1/2 mv squared, right?
You're just gonna have to memorize this.
Yeah, just remember this one, right? If you double the speed, it's 4 times the distance. If you triple the speed, it's 9
It was like
times the distance.
there was like a Mythbusters thing, you know, where like, it was like, with the cap, like a car going at
No,
50
I
miles an
did
hour
something
closer
like
and then 100 miles an hour farther away or whatever.
Yep.
Crashing into the wall, will it like?
Yeah, this is how you think of it.
What is this?
Oh, I thought of it as 50 times 4, or 50 times 4 is 100, just because 5 times 4,
Yep.
so it went quarter faster. I don't know, that makes sense, so, but I didn't know, it really does, man. It does, because I thought it was in 25, so it's.
The big key here is
Okay.
velocity squared. That's all.
Oh, so it's like you're
Double.
So if you double, it's 2 squared, right? If you triple, it's 3 squared. If you quadruple, it's 4 squared. And that's 4, 9, 16. Right. Ball's thrown in the air, 100 joules. Transforms to gravitational potential energy at the top, and then it returns back to its original air, its original level. What is the kinetic energy if I throw it with 100?
Same thing, it's gonna come down.
It's going to come down as 100, right?
But don't you guys try? I thought you did.
I like that.
Yeah, it's around.
So 100 joules up, 100 joules down. So you're saying C. What about this one? Isn't it going the opposite direction? Hey, is energy a vector or is energy scalar?
Energy's being measured.
It's not a vector.
So why do we talk about negative work?
Yeah, so it is negative.
So work is a
Except
vector.
both.
Yeah. In this case, I took both in this test.
But what's the right answer for this line?
I would say 100. I mean, 100. Right? Because it's an opposite. It's an energy in the opposite direction. Potential energy, it's less important. The direction is less important because it's going to be clear. The kinetic energy, direction matters, right? It's kinetic energy in a very particular direction, even with the velocity.
Is this 5 4 times? Number 5? is the
Number
other
5.
times or 8?
Now Newton pushes an object with twice the force for twice the distance. Yep. So work equals force times distance.
They just did 2 times.
And we're 2 forces times 2 distances. That equals 4 times the work. Alright, next one. Yeah, here's, actually this number 2 here is actually tricky.
Okay, let's do 2.
No, one.
500 watt electric motor.
You
We already did one, right?
9.8 times.
Okay, so.
Oh, I just made up new numbers, right?
Yeah.
Number 1. I did 1400 and 1.12 meters.
Wait, I forgot how to do this. Okay, so you do, wait, what's the formula?
I'm gonna erase all this.
Mass times gravity times.
So potential energy is equal to mgh, right? Also, if you go back to your good stuff on this, right? The good stuff here. potential energy or work of lifting. Do you guys see or lifting? Work of lifting. This is just regular work. But when you're lifting something, work equals mass times gravity times height.
If we're not.
Is that the same as?
Right? Because this is
It's
force,
yes, so it doesn't matter.
this is distance. Alright? Okay, so we go back to the problem. Let's, you want to do number 2? Alright, you guys got number 1, you're confident with that. Alright. So number 2, I have a 500 watt electric motor is turned on for 60 seconds. How much energy does it use? Well, let's write down, let's go through, like, you guys know, like best practices, right? I know power equals 500 watts. I know time equals 60 seconds. And I'm looking for work.
Wait,
Or
what's 1,000 times?
Yeah, it's 55
work is what I don't know. Or energy is what I don't know.
Wait, P is.
This
what?
is the trick of this question, was you need to remember work and energy are the same thing. Okay? You guys remember that for me? Thursday? Work and energy are the same thing. So do I have a formula with P, T, and W? Power equals work divided by time. Solve for W. So
times T.
500 watts times 60 seconds equals work. That is what? Watt seconds, right? Which is also
Wait, what is 1,000 times
9,800.
Yeah.
All right, softball, 300 joules of kinetic energy. It's flying through the air. Lena just threw it. You guys know Lena? Graduated last year. Yeah, she's been hanging around lately. Throws a softball, 300 joules of kinetic energy. How much work must Danielle do? Stop. Don't even have to do it.
No, you don't.
You just need to know that work is equal to energy. In this case, because you're stopping something, it's a negative work. Right? Why is it negative work? Do you guys remember?
Correct.
Work equals force times displacement times cosine of theta. Right? This is the actual work formula. Right here. Isabel, remember this?
Yes. I know how to do that.
Right? What is that angle in this case?
Zero. Sign.
Yeah.
Angle right there.
What is the angle between the force that the catcher's mitt is applying and the direction of motion,
Negative.
or the displacement of the ball? Displacement's this way, force is that way. What's the angle between those? What's the angle between? That would be zero. It's not. Going that way. Everything's going out. It's the angle between this way. 180 degrees. Cosine of 180 degrees is negative 1.
That's what I was saying.
I didn't realize where you were going, but I just wanted you to remember where it's coming from.
Because like you do cosine of 180 equals something over something.
Well, you're getting into your question, don't worry about it.
Well, that's what we do in geometry.
Yeah. That's if you're solving a triangle. We're just measuring it. It's 180 degrees.
So you can put cosine of 180 and negative 1. But if you put it second cosine, you know,
I'm not talking about. multi-step problem. Very, very critical, girls, very critical that you get the beginning right so that your correct answer carries. Alright,
Number B is the same
number B? Okay, snowy day, 100 kilogram truck, 20 meters per second, hits the brakes and skids to a stop over a distance of 20 meters. What's the kinetic energy of the truck before it starts to try to stop?
Joules.
Yeah, so what's the formula again?
Half times average times.
This is 1,000. Kilograms, velocity equals 20 meters per second. Distance equals 20 meters. KE equals question mark, right? So KE
Equals
One
one
half
half times 1,000
squared.
times 20 squared.
Alright, so it's 500 times what? 400?
No, it's just like 1 and 4.
20 times 2 is 40, that's 100. Meters squared per second squared. Alright, that equals. We will get this all over.
You're not gonna do
Equals how much? Joules, right? Kilogram meter squared per second squared?
So the kinetic energy is 200,000.
Yep. How much work is needed to stop the truck? Negative 200,000. Stop is negative. What's the average force that slows the truck? Right? Well, if this is the work,
Divided by 12.
work equals negative 200,000 joules. And it's equal to force times displacement. 20 meters. Right? Then force equals, or work equals force times displacement. Negative 200,000 joules. Force times 20 meters. Equals size by 20 meters. 10,000. What?
Wait, so in joule,
No, we're not gonna have,
wait, how does
we're
it?
not gonna do that. We never really went over it, but.
Wait, no, you should have made me use it, right? Number C?
No, we were.
No, I'm asking for.
No, the other page.
You said for that, remember how.
Yeah, so like this one here,
Oh, the vacuum thing? And then you
yeah,
well border for us, the next one. Fine.
Yeah. And these are going kind of systems that have those systems. Another way to
Okay, so can we cross out 5, wait, 6 and 7? Can
You
we
just
cross
cross
out?
out this page.
I'll do it.
You might see a teacher's question or something, which is very general.
Cross it out.
I want you to know what mechanical means. I say we need nothing about this.
Well, there you go.
There you go.
Now let's do number 5.
All right. What's the power output of each of these two people, Becky and Bobby? This gap of space I left for you is actually way enough. This part of the question.
Wait, so, student.
How do you find power?
Wait, I have to go.
Number 5.
We have to go to the good stuff. So we're trying, it's power equals watts time divided by time.
It'll work.
What is this watt?
Can't do watts, right, that's not.
Power is measured in watts.
Well, it doesn't mean that you can't divide by watts. Divide by 900 watts, you can divide by watts.
That's all right. This is actually, it's a really
You
tricky
can't
thing about
divide
this.
anything by time, you have to divide it by something seconds.
All right, you guys are kind of arguing two sides of the same.
Yeah.
So, just be careful, Isabel, the moral of the story, if you will, here. Be careful with capital W's in this unit because it could mean watts if you're talking about a measure of unit or a unit of measure, or it could be work if you're talking about a variable problem. I would just say let's write out watts. And if we don't write it out, let's make that.
This is just stuff you.
I started doing just, all right, making little lines on top of the W, but then it's still hard to remember, well, which one? So let's write out box, W's a word. Okay. All right, so power equals work divided by time. What do we know? We know mass, 60 kilograms or 90 kilograms. What else do you know? Distance or height, 2 meters. Time,
Were you doing something special for our last morning meeting or not?
no.
Wait, are we supposed to do the?
Well, I know mass, I know
We
age,
should find work first.
I know time. Yes, we need to, we don't know what this is, right? We're looking for power. We don't know work. Well,
So we
work-
have to do force times.
Work equals
Force times distance.
force times distance. Well, what's the force in this case?
You do the mass times 9.8.
Right. She's gonna equal mass times gravity.
So we have to do each one, be the figure of the E and Bobby. So you have to do 60 times 9.8.
Yep.
What?
Negative 60.
60 times 9.8 is like 590. All right, I'm gonna zoom in a little bit so I can squeeze this in here a little bit. 180. All right, so Becky Becky equals 60 kilograms times 9.8 meters per second squared times distance, 2 meters.
So Becky's work is 1,100 and something.
176 what?
Joules. Joules.
Watts.
Joules.
Watts.
Yeah, so you see it's confusing.
Joules.
Yeah. And
Right?
then you have to find Bobby's,
Bobby,
which is 90 times 9.8 is
Bobby is here, is 90 kilograms work right now so far. And
So now.
he is how much work?
No, 1, 5, 6, 7. All of these.
1, 7, 6 quarters rules. Okay. So Bobby's power is work divided by time. Over 2 seconds. How's she gonna do this?
It's 8. Oh, wait, we're stupid. I need to times it. Yeah, it's 8, 8, 2. And then 5, 8, 8. So it's pointless.
Just because you times it by 2 and then you end up dividing by 2 again?
Yeah, it's pointless.
2 meters.
You have to do with
Alright, so he is, how much?
Bobby's 882.
Oh, wait, it's
2
each
what? Not joules.
Watts.
Lots.
See, I was, okay, I was saying that, I thought this was the final answer when 765. That's what I was
Because
saying.
you've already done it, you're not following along because you've already done it though. That's fine.
Yeah.
And then Becky's power equals
No, no,
1,
that's his Bobby's power.
1176 over 2.
588.
Oh, wait.
882 is Bobby's, yes.
Yep, and Becky's is 588.
Finally. It's because he has
Alright.
bigger mass.
Yes.
Guys, he's wheezy.
Miss Shane's dog.
Kelly was like, sorry to spend time with Weezy. That's Miss Shane's dog.
I'm sorry. No, it's a really cute.
She's training him to be the physical therapist.
Yeah.
He's certified already.
Oh, yeah, she wanted me to.
Why didn't you ever switch?
I did tell her.
Switch.
Yeah, I told her.
How did you talk to her? Like,
Right, it was really awkward. It's just, it's.
Hey, I used to do it too, but you know,
it's
it's
awkward.
sections of like this.
Yeah.
Everybody switched them.
However, you should put in a request for, you should put in a request for where you want.
Very switched.
Yeah,
Second he was
Sorry,
skating.
I remember when she was like, I don't want to talk with you before you split.
So, oh, it was after Thanksgiving dinner, and I had to like stay there. And she was like, I was like, it was totally like personal, like I really just don't like that much. And I go, she was like, oh, is this like personal? I'm like, no. Yeah.
No, like, everyone in the whole
Didn't know what to
school
say.
wanted to switch except her and Miss Michaels. Like, they were completely oblivious. Like, they did not know that I wanted to switch. Like, everyone, like Tanner, everyone knew that I wanted to switch. And
Isabel, I suspect you're not good at being received.
Yeah, no offense.
no, but like, she was oblivious. You know, like, I knew
We
I
know
wanted.
what you're thinking, which is one of the reasons we love you.
That's not one of the reasons why I like her.
Oh,
Shit!
hey,
You can't be serious. Sorry.
Oh crap.
You got the F bomb.
and she doesn't even realize it. That's the
It's
point.
just like natural.
Yeah, she says that we're alive.
It's part of the English language.
Yeah. Yes.
My dad always yells at me. He's like, "Only stupid people swear." And I was like, "Oh God, if I swear, are you stupid?" And he's like, "Yes, I am."
Okay, if I swear for my dad,
wants better
I would be
people.
like thrown out the window.
No, no, if I say
I
ever.
don't think you guys understand.
One time I said the F word right in front of my dad, and he's like, "Are you kidding me?" He yells at me.
My dad's
I'm
like,
you do.
My dad's like, no horses, rest of the year. He said it to her. I'm like,
But you
oh,
know how
God.
you say like do it all the time, or bro, you say bro.
I'm like, no, my dad hates when I say that. Like, bro, get over here. I do not call me bro.
No, my dad, I said dude, I used to.
And my grandma would always tell me that thing when she got home.
I'm like, brother, get over here, kids.
I was like,
I called him Broha once. I'm
"What?"
sorry.
And she
I'm
was
like,
like,
Broha.
I was like,
my
my
dad
like,
hates
looked
that.
at
I was like, this is really hard to say.
So I said that once when I was little, and he was like, "Where did you hear that?"
And I can
"You,
say my mom,
Daddy."
like, she lets
He
me.
was like,
Oh yeah, my mom swears too.
Don't say
"Yeah."
it.
Like, you're
My dad thinks crap.
My dad.
Yeah, I can see your dad swear.
My mom
Alright.
always yells at me if I like say a bad word in front of her. She's like, "I don't want to ever hear you using that."
No, my
language."
mom's chill.
And
It's
I'm
my
like,
dad. Like, crap.
All right, we did a practice like this already, right?
"I'm
Yeah.
gonna move my dad to
Yeah, we're gonna do that.
You guys want to practice conversion?
Yeah.
All right,
Should we go to the good stuff back?
2611 watts
Yeah, so you go to the good stuff, we can see this.
We'll solve it.
Yeah, so you just, you keep it there.
Yeah, it's right there. Perfect.
Okay, so lots of little.
Oh, I don't think I put that one in.
Yeah, you did.
Okay, guys.
Oh, there, it's up here.
Where is it?
Up on the top. Here's the conversions.
Wait, can we go on support power blocks on top?
Yeah, how do you set this up?
You put,
You put blocks on power.
you put,
That's what I thought.
no, you. It's like this.
2611 over.
So you
Yeah, yeah,
you
you
start with your
divide it
number over
by
1. 2611 watts.
Over one, and then you do one
Multiply.
horsepower over.
Okay, yeah, no, it's when you went to this one.
So it's just a second.
Wait, can you go to the soapbox and see?
Wait, were you like mean to her during advisory lunch?
No, I didn't talk to her, but I didn't, she didn't even know I had a sense of humor at all, like, I didn't talk whatsoever.
Like, she like, she say like, she competition, like, sort of like,
You have to like get
Oh,
like,
is this a split advisory? Is it
Yeah.
2 advisories?
Yeah.
Okay.
you have to like understand her, like,
This bond
you know when she like checks your outfits
lavishly
and
that I
what it
did
is,
too.
you have to be really funny and she's like, there you go. No, I was like really nice. No, I just.
No, like I kind of switched around
Oh,
over
you're
and
today?
pulled
I'm
it
like, I
out.
was like so.
And I had on a tank top. Like it was
So
like
protective.
she
She's
had,
like,
kind
your
of-
shorts are down to your ankles. You can't
She's
leave.
like,
I didn't
I
even know she was signed until like a few days.
I was like, it's like it wasn't like an inappropriate outfit at
Press
all.
down there?
No, it was pants.
I
I
would
would
grab
grab black leggings, a
just
white
kept
tank top, and then like this
Like
like
so much husband's
like this nice dressy kind of tank top
She-
over it with like
and she
stripes. You couldn't see anything. It like cut off here.
The answer
It was like
I
four
guess
inches.
with tank tops, I think it's the under your arm that you want to
Okay,
be
No,
stuck.
it fitted.
She like flips her crap with your shorts aren't down to your ankles. Like,
And my mom wouldn't make. My mom was probably fine.
Literally.
Those are just pants.
They put it down, but she wants your shorts like down here. We're all like,
oh.
Yeah, LCD is like, it's like
Who's this? Shay.
shit. On the way to like socials or something.
Keep in mind, her job is that she needs to sell the
Still the school. I know it's still the school.
Oh my god, when she's there, she's like so overpowered. When you say like, I love this school, like remember, like it's really good. She's like a very good salesman, but like,
What does she do?
like she, no, like,
Give an
no
example.
comment. She's just like very like,
Protective
yeah.
about the school.
She's very, like, Miss Bad, she's my daughter for a while, she's like, she's, as my boss, she's very hard to approach.
Yeah, no, they're so scared of her spot. They're so scared.
She's very hard to approach.
You're like, oh my god, you can't
It's
just like
bad
go
that
up
you
to
guys
her.
don't do that.
It's like,
It is true.
do you think our administration is good?
What is administration?
I heard like teachers is mean.
It's good.
What is
It's like everything.
administration mean?
It's like the spheres.
It's like every administration. There's some things that they're great at, some things that they could be
Is she
better
part
at.
of the
this beard is really good. I think
No, all she does is ask parents for money, like literally. Remember
Yes,
dinner?
yes.
Lunch with her? Money. My dad was, it was like the first week. Like she hadn't done any benefit towards me because I just came to the school. Like I hadn't like, it was one thing if like, oh, I'm gonna just like be great at this. No, all she does is my dad was it was like the first week. Like, that's ridiculous.
Wait, how many seconds are in
She's
this?
asking money way too much.
Yeah, we are. Compared to other private schools, yes.
Yeah.
I know, all I could do is like,
Why the hell do they charge $50,000? It's like not even a nice school.
Part of the difficulty is girls' schools are generally not supported by alumni at the same level that
It's-
boys do.
Like, money dumped on them, like.
And I mean, there are numbers, there's numbers and factors of that.
Yeah, no, yes, not, but it's tiny.
Including,
We have
including the fact
no
that
good.
women still
Not
don't
compared
earn as
to
much
like
money.
Wilshire,
as men.
like,
Supporters.
or like,
That's one thing.
these porters like an indoor pool, or like,
Yeah, they're
even
campus
like,
moms.
our gym is like disgusting. I don't even do those kind of sports.
I got a Rex.
This conversion.
There's a lot of nice things. There's a lot of capital improvement happening right now.
But our dorm is that nice, that one.
There's one.
But that, wait, that other dorm though.
She
has
be
like
like
2 stories. What school is that they have the 2-story dorm? No, like your
What?
room is 2 stories.
What?
I don't know, it was, some girls were talking about it. Like, it's a real, yeah. It's like, I don't know, it's not different. It's one of those. West Dover and West Dover. Which one?
Hours, minutes the same.
Wait. What W school is it all day students? Like Westminster is all day students?
Watkinson.
No, it's right here, there's
Yeah,
one that's right here. No, that's 5 minutes away.
What?
I've never heard of
Watkinson is like.
It's at the University of Hartford campus. And it's a day school.
The one that we play sports with, don't we play sports with?
It's sometimes.
We played softball, we had a grass field. Oh, yeah. I heard, played softball in a grass field.
No, if you go to that school, Canterbury.
Oh,
It's
soccer
middle
fields
nowhere.
are
Disgusting. And I went there
Well,
for.
that's right, Nick
for-
Wilson.
For squash, we had Milford, and it's in the middle of nowhere, like,
I know,
what the heck?
Wait, hold on, we have 20 minutes left, we try and like finish.
Yeah, I did go last one.
This is our
20
last.
minutes of physics, hopefully for life, unless you guys fail and then you're back. Which you
That's
can.
all what you get.
29.
Number
Can I
2.
flip to the page now?
No, number 3 is 29. Really, I'll explain it later.
Did you get?
It's
How'd you get
29.
there?
Oh, you do joules over 1, and then you do calories.
You multiply it, right?
Yeah. But though, like, you have to tell which
This
one.
looks like about 3.5, is that right?
Yeah, so you. And then on, okay, so you do 65 miles over 1 hour. And then oh shoot, what was that? That was, like, I have the good stuff, yeah.
What's the conversion here?
0.239 hours.
Okay. Okay, I'll go with this. And then you have to do.
And that's suggested is about 500.
Okay, so then you have to do, so that's miles, so about mile. And then like this. Like, you know, line. So then you do this,
Yeah.
and then you do one, no, one, yeah, and 1 mile is down here, so the miles cancel out.
No, you did.
Oh, okay. Miles cancel out.
Yeah, and then, yeah, and then you do this one, just seconds. And 60 times what? 60 times 60 is what?
3,600.
Okay, so then, no, but then you put in, you put 6 seconds down here.
No, do it backwards again.
So you do 1 hour equals 3,600 seconds. The hour is about. So now you do this times this divided by this. Do you get it?
Oh, yeah.
You get 20.
29.05.
And it's remaining.
God, it makes us well.
Did the bell just?
Now we have
Nice
one.
question.
Yeah, nice one, bro.
I love the bell, right? I actually.
All right, feeling good about work energy power? Here, I'll do it more the way it was done in your conversion.
Wait, don't you do it like that?
You can do it this way. In 1 hour, there's 60 minutes. And in 1 minute, there's 60 seconds. You still end up coming out to 29. Now the minutes cancel. And the hours
Okay.
cancel. 60 times 60 is 36.
Anya, you have the units for centrifugal acceleration, stuff like that. Oh, you filled it.
All right,
You have the third pack.
centrifugal acceleration. What's the unit of centrifugal acceleration?
Meters per second.
Nope.
do it.
Centrifugal acceleration is measured in.
Yeah, I
Yes.
got it wrong.
Why? Meters per second squared.
Yeah, that's what I said.
You shouldn't have gotten that wrong. It's an acceleration.
Yeah.
Standard unit of acceleration. Meters per second squared. How about centrifugal force?
Newton.
Newtons. Here's a tricky
Meters per
one.
second.
Angular speed,
Hold on.
not meters per second.
Oh, yeah, it's that weird.
So weird. Unit circle,
Oh, radians per second.
radians.
And then it's, what is it, like pi per minute or something? Or what would we give
Seconds.
So one
Period
circle,
seconds.
one complete circle is equal to 2 pi radians,
Yeah.
right? But just because there's radians there doesn't necessarily mean that you have to add pi's and stuff.
No, I know, I was just saying, there was radians per second and then there was something else.
There's RPM,
Degrees per second.
No,
degrees per second.
or whatever you're doing with these podcasts that you do.
Period. What is period? What is it? How do we define period?
It's seconds.
The time it takes to do what? Complete
Work.
complete a cycle. Alright, a cycle
Minutes,
could mean
years,
a
hours.
circle, it could mean a wave, up and down, right? Period is the time it takes to complete a cycle. So what do we measure time in? That's not the standard.
Minutes,
right?
years, or hours.
Hours would go over here. Okay. Hours, minutes, years,
Round.
force.
Course.
Wait, what's the bottom one? Minute? Wait, no, but what's the centrifugal acceleration from?
Yeah,
What's
why
another
is-
unit of acceleration?
Feet per second squared.
Feet per second squared, that's great. Kilometers per hour per second.
It's a unit for pretty big.
All right, index cards. Very good use of index cards. Units. Okay. This is a great, put the ones, save space on your index card, but only put in the ones that you don't know. Processes to help you solve problems.
Yeah, but I'm wrong.
That's fine.
Yes, we all units on it.
Units.
Like, you know, yours.
No, I don't. I'm
Yeah,
gonna play
I'm
I
proctoring
can
tests.
never do it.
I
I
just
can't
want
risk
part
me
of the
remembering one thing.
Period, the test period.
Color coding.
What is that crap? Just eat.
It's huge.
Oh, you
Three by
have
six.
that fun.
Like, the whole one side.
No, but that's, I think I'm proctoring this year.
Oh my god, it was like that. To write all of them.
And, there's a bunch of teacher volunteers who proctor
I'll
these
figure out.
sometimes.
You're not making what?
Oh my gosh, man, I just sent you this tomorrow.
Oh god.
Do you know the second was?
Nat, you made it?
Yeah.
Lucy?
On there, I feel like past week.
I didn't finish it, but
Neither did I.
I finished it. I did it from like 11 o'clock.
I did too.
Why do you guys take Latin? Bad choice.
No, I
don't
don't.
take Latin.
Just so you get ahead of the
You take Chinese then.
Yeah, you're
Yeah, Latin's too hard.
No, Land's really helpful for English. That's why I took Latin at the beginning. Like, I struggled with reading so much in the beginning. Like, in like second grade in England, Latin helps with all your like stuff.
All right, you guys want to do multiple choice
Did
now?
you?
Let's take it.
They're
Overachieving.
Why didn't you?
Who can explain the difference between revolution and rotation?
Oh my god, I have
like
it.
something's forward.
No, okay, you explain this.
No?
I have it.
Wait.
Difference between rotation and revolution.
Okay, so, you,
Alright.
okay, so you,
Let's give it.
Okay, so so when you're, Catherine, stop. Okay, so when you're on the world, and you are rotating while you're on the earth.
What's external?
Oh, this is.
Yeah, when you are rotating on the
Me
earth,
as a person on the earth, I'm not rotating.
One's internal.
the earth is rotating, hold up, on.
Earth is rotating.
Yes, and then the earth is revolving around the sun.
Yes, that's a great example.
Yes.
So rotating on its axis, revolving around the sun. What is the key?
The sun is the
What
earth
number are we
revolves
on?
around, the earth rotates around its own axis, and then the earth revolves around the sun's axis.
Right,
So
so-
What number are we on?
The way I describe it is internal axis, external
Which
axis,
one's showing?
right? Those are big words that can help you.
Rotating.
Rotating is internal, meaning the center of rotation is somewhere inside the object that's actually spinning. Revolution means the center of rotation is outside the object that is making spin. Alright, good. Inward or outward force? What's applying the force? So, washing machine. You guys do front loaders or top loaders?
No, top loader, top loader.
You
I
put
don't
your
really
clothes in
want
on the,
to-
you
Yeah.
put your clothes down or you put your clothes in?
No, down.
Alright, so we have some of both. You have an in, I have an in.
have an in too.
No. It's-
So, but
it's
both of them
more
do the same thing.
Yeah.
They spin at high speeds.
So they're all the way down.
Right.
Oh, yeah, dryers.
Well, dryer spins too, but the dryer doesn't spin for this reason. It's fine. Dryer just spins to keep mixing things up.
Yeah.
Washing machine spins fast, right? Fast enough that if it's not right, the whole thing goes like it shakes, right?
Then switching is so scary. Oh
Have you guys ever seen like washing machines walk?
my god. It used to spaz. Yes, it used to. And Smith and no one would flip out. It was
Yeah.
so scary.
So, that happens when it's out of balance, but it's spinning fast for a very particular purpose. What is it?
For friction. Yeah, to dry it out.
No, because you need like,
Just dry it out, but not for friction.
cause like when I have to be very clean to look my shirt.
So whip it out. So whiplash it. I don't
And
know.
like my mom told me immediately put
It's
it
going
in the
to
wash.
Right.
Because like I need to scrub it with some soap and everything and then let it like go.
Yep. Well, a washing machine when it's washing, when it has soap and water, it's actually, a front loader is spinning very slowly, it's just kind of flipping clothes over and over and over again. And then a top loader actually goes like this, it goes back and forth. It's called an agitator. Agitator.
No, because like there's holes in the thing so the water can go through the clothes.
Yes, this is the key. You ever notice the drum that you're sitting in, where your clothes are sitting in on the top loader or a front loader, has a bunch of holes in it, right? What did you say the holes do?
Let's water go
That's water goes through, not the clothes. Right, so the clothes stay in, but the water goes out.
I know.
through.
So
I know.
the drum applies a force to the clothes into the water. But it's the water squeezes out the holes, the clothes can't. So it spins really fast in order to apply what kind of force?
Inward.
Inward, what's the name of it? Centripetal force. Alright? The drum applies centripetal force to the clothes to keep them moving in a circle. What does the water do since the holes are there?
Centripetal force, same thing.
Where does the water go? In what direction?
Applying centripetal force on the inward to keep it moving in a circle.
It does end up outward, but it doesn't end up outward straight out from the center of the circle, and it's up outward
Inward.
tangentially, right?
Oh, tangent.
Right. So if I soaked this ball with water and I threw it and it was spinning, and water was flying off of it, water's flying off this tennis ball.
You like bounce the water comes off.
Right, you're bouncing, the water's coming off. But let's say it's just flying through the air spinning. Right? Does the water come off this way?
No, it's in a circle.
Right, as it's spinning? Or is it coming off?
Yeah. Okay, so Oms and I, or no, me and Cindy and I we were at the tennis courts, and we didn't have tennis balls, so we went to go to the back to go get tennis balls.
Yep.
And we threw them over, and I threw it to Sydney, and the water, you could see it was so cold.
Like this.
Yeah, it was so cold.
Right? The water on a spinning tennis ball flying off
This way. Came off.
spins off like this, not like this. Alright?
Obviously not.
Alright? Like this.
And number 4 is the same thing, it's a centrifugal force, inward to keep the bucket moving circle. You keep
Right.
when
So
you want
bucket of water.
Water pushes against the bottom.
Water pushes against the bottom
When
as an
you're
action
supplying
reaction
centrifugal
pair
force.
of the bottom pushing against the water. So the water's in motion,
Yes.
the bucket is pushing the water down or towards the center of the circle.
Yeah, well, you're supplying force to keep it moving in a circle.
Should I do this? Do I have time?
Midterm, guys, this was our midterm packet,
Here's the bucket that Tanner brought back. All right, water's in here.
Guys, one meeting and then. What are you gonna do long walking hours?
Water.
Oh, don't you dare.
Right over on you, ready?
No! Mr. Patrick, not my note! Not my note! No!
Well, we all know what's gonna happen, right?
No! We don't trust it!
Water's in motion.
Patrick, stop! Freaking, holy shit! I'm dying.
I already did it once.
We just did it.
I don't trust it. What's the water going out? That's You're applying centrifugal force. And it's
I'm applying centrifugal force.
As the water pushing against the bottom of the pan.
And my centripetal acceleration is greater than gravity. It's greater than gravity, so gravity doesn't have time to act on it over top of the circle.
I don't trust
You
gravity.
guys have never done this as kids?
I have no trust.
I do it all the time.
It's fun.
Yeah, but in classroom, you drop that every day.
Oh, you're wet.
Yeah, no
Yes.
Yes, and they said you have no clothes to change into.
Yeah. Oh, doesn't everybody should keep spare vespers on hand at all times, right?
No, Mr. Patrick.
No,
I did that. You only got counselors.
I love that you didn't just run away, you took all the desks.
I just ran.
All right,
Oops, I
water doesn't fall out because the centripetal acceleration I'm providing is greater than gravity, okay?
Look, this is our midterm review. Do you remember this? You gave us 3
Why
pages
is all
for a
why
50-page
is
test.
Perfect.
This was nothing. It did not prepare us.
I guess you're done?
No, I'm throwing out paper. I was just leaving. I knew you should.
Good, recycle.
What did you say?
Oh, I'm sorry. You go recycle the paper. There's the recycling bin.
Right there.
The
below you.
element.
Recycling bin?
Yes.
Weird stuff.
So that's what Mr. Rankin has, like, what the heck? Okay, well, let's say.
What did I say about?
Said something about gravity.
Oh, so the centripetal acceleration I provide to the bucket is greater than gravity, greater than 9.8. So the net force at the top is 0 or more towards the centripetal than it is towards gravity. Yeah, that used to have heads. All right. You guys okay with solving these? Linear velocity, angular velocity? Okay, there are a group of girls coming to C block today. You guys wanted to come and talk more?
We all have English.
Okay, that's what I figured. I am around all week. Please just email me and set up an appointment. You're free.
He's a meeting.
They were free. physics for 1 year.
Bye, thank you so much for everything.
All right. Thank you for such a
Peace,
genuine gratitude.
Thank you.
Hey. It's not too
I'm sorry, I'm putting my Spanish down.
too private.
They're Spanish.
I know.
You see, they're appropriate.
I saw, even though I didn't want to.
They're called spandex. It's not like not my roommate runs around in her underwear. Yeah, in the dorm.
That was Patrick, thank you.
You're welcome.
That's why you're not a dorm paradise from Patrick.
Well, I am a dorm parent, and I've seen that before. Not her, but it happens. And
She's
then
like, it looks like.
what happens
It looks like
when it's
spaghetti.
me and somebody doing that, and it's like deer in headlights. People just freeze. And I'm like, all right, I'm turning around, and then they run away.
Wait, I still want to learn those equations. You never learned them.
What equation?
For chemistry.
Oh, it's not equations. It's a system of how you decide what number to round it. Because you know how the calculator gives you ridiculously 52.6324. It tells you what you round to. And it's called significant figures. And you'll have plenty of time to learn it next year. That'll be fine.